Look up at the night sky, a vast dark canvas scattered with stars, each a sun potentially harboring its own planets and stories. It's a humbling sight, isn't it? But between those stars, lurking in the inky blackness, lie the universe's greatest mysteries: black holes. These enigmatic objects challenge our understanding of reality itself. For decades we've seen them as cosmic monsters, insatiable devourers, relentlessly consuming everything, even light, leaving nothing to escape their gravitational clutches. They've been the ultimate symbol of destruction. But what if that's not the whole story? What if black holes are also beginnings? A gateway, not just an end? What if our understanding has been incomplete? The idea sounds like science fiction, a hidden door to another dimension, a cosmic shortcut, or even a portal to another universe entirely. It's a concept that has fueled countless stories. Yet, some of the brightest minds in physics are taking this possibility seriously. They're finding hints, subtle clues and complex equations, that black holes might be more than just dead ends, more than just cosmic vacuum cleaners. Imagine the cosmos as an ocean, vast and deep, with black holes as whirlpools, places where spacetime's currents twist and churn, pulling everything into the unknown with irresistible force. We've always assumed anything caught is lost forever, crushed into oblivion. But what if these whirlpools don't just lead to the bottom, but open into another ocean, a different realm of existence? The quest to answer this profound question takes us to the very edge of space and time, to the event horizon itself. So let's embark on a journey, guided by the principles of physics and fueled by insatiable curiosity, to the edge of a black hole. We'll ask the ultimate question: what lies on the other side? Are black holes truly cosmic graveyards, the final resting place for matter and energy? Or could they be birth canals, the genesis points for entirely new worlds, new universes even? The story of black holes, as we are beginning to understand it, is not just about destruction but about transformation, passage, and the tantalizing possibility of new worlds being born from the ashes of the old. The cosmos is whispering a secret, a profound truth about the nature of reality, and we're finally learning how to listen, how to decipher the language of the universe. To see if a black hole can be a portal, a gateway to another place or even another time, we need to understand their fundamental nature. We first need to know what it is. What are the key components that define these enigmatic objects? Gravity, as Einstein so elegantly showed, isn't just a force but rather the warping of space-time itself. It's the curvature of the fabric of the universe. Imagine a bowling ball placed on a stretched rubber sheet. The sheet bends and dips, and marbles representing planets or stars roll toward it, drawn in by the curvature. That's gravity in action. A black hole is gravity taken to the extreme. It's gravity amplified beyond anything we can readily comprehend. An object crammed with so much mass into so little space, it warps space-time into a bottomless pit, an infinitely deep well. Born from the dramatic collapse of a massive star at the end of its life, it shrinks to an infinitely small point called the singularity, a place where our current understanding of physics simply breaks down. Surrounding this singularity is the event horizon, the point of no return, the boundary beyond which escape is impossible. Cross the event horizon and nothing, not even light, the fastest thing in the universe, can escape the black hole's relentless pull. That's why black holes are black. They absorb all light that comes their way. Light can't get out to tell us what's inside, meaning any information that crosses the event horizon is effectively lost to the outside universe. The event horizon is, in a way, the edge of the known universe. Beyond it, no information can ever return to us. So, in its simplest form, a black hole has a singularity at its very center, and an event horizon, a spherical boundary surrounding it. For a long time that was the end of the story, at least according to classical physics. It was seen as a cosmic prison, relentlessly crushing and destroying anything unfortunate enough to fall in. But physics, thankfully, is never satisfied with dead ends. It always seeks to push the boundaries of what we know. Some physicists, driven by curiosity and a thirst for understanding, began to wonder, does the story really end at the singularity? Is that truly the final word on the matter? Could there be more, something else entirely, lurking beyond the event horizon, hidden from our view? The mystery of black holes, it turns out, is far from settled. It's an active area of research, full of unanswered questions, and that's precisely where things get incredibly interesting, and where the real speculation begins. The first real hint that black holes might be far more than just cosmic prisons, inescapable voids in the fabric of space-time, actually came from the brilliant mind of Einstein himself. He was always pushing the boundaries of what we thought was possible. Back in 1935, in collaboration with Nathan Rosen, he made a profound discovery. The complex math describing black holes strongly suggested a potential connection, a theoretical bridge, linking it to another, perhaps very distant region of spacetime. This concept, born from pure mathematics, eventually became known as the Einstein-Rosen Bridge, or as it's more famously and popularly known, a wormhole, a shortcut through the cosmos. The core idea was revolutionary. A black hole could potentially act as a shortcut, a tunnel carved through the very fabric of spacetime, potentially connecting incredibly distant places within our own universe, or even, theoretically, acting as a bridge to entirely different universes. Theoretically, if wormholes existed and were traversable, you could conceivably enter a black hole and then, almost impossibly, emerge from a white hole, hypothetically its opposite, somewhere else entirely. But alas, there was a significant catch. The original Einstein-Rosen wormhole, as described, was inherently unstable, collapsing almost instantaneously upon formation. It was like a door that slammed shut with incredible speed, long before anything, even light, could ever hope to pass through its fleeting opening. For many decades, these wormholes remained largely a mathematical curiosity, an intriguing theoretical construct. Yet despite the challenges, the underlying idea was simply too compelling, too tantalizing, for physicists to completely ignore. Maybe, just maybe, the singularity at the heart of a black hole wasn't necessarily the absolute end, but instead the entrance to a cosmic tunnel, a gateway to somewhere else entirely. The groundbreaking work of Einstein and Rosen had opened our minds to a universe of stranger, more mind-bending possibilities. And so, the quest was officially on. Could a wormhole, against all odds, ever be held open long enough to be traversable? New generations of physicists took up the challenge, exploring where gravity meets quantum physics. One idea, loop quantum gravity, says space-time is made of tiny loops, so you can't crush matter to a true singularity. Instead, matter bounces back, forming a Planck star, a possible gateway to a new universe. Another idea, the holographic principle, suggests all information about what falls into a black hole is stored on its surface, like a cosmic hard drive. Black holes might not destroy information, but encode it. Physicists like Kip Thorne and Carroll explore whether wormholes could be made traversable, using exotic matter to keep them open. These aren't just wild ideas, they're pushing the boundaries of what's possible. Black holes could be more than destroyers, they might be cosmic bridges. Theoretical physics is mapping the unknown. The universe may be stranger than we ever imagined. The idea of black holes as portals gets wilder when we consider the multiverse. Eternal inflation suggests our universe is just one bubble in a vast cosmic foam, with new universes constantly forming. Some physicists think black holes could spark the birth of new universes, each black hole a seed for another cosmos. Our universe might have been born from a black hole in a parent universe. String theory's brain cosmology imagines our universe as a sheet in a higher dimensional space with other universes floating nearby. Gravity might leak between these brains and black holes could create tunnels, wormholes connecting them. Falling into such a black hole could transport you to another universe with different laws of physics. It's the ultimate leap between realities. These theories are speculative, but they give black holes a stunning cosmic context. They suggest black holes might be the gateways to the multiverse. There's a deep puzzle in black hole physics, the information paradox. Quantum mechanics says information can't be destroyed, only transformed. But when something falls into a black hole, it seems lost forever. As black holes evaporate via Hawking radiation, the information appears to vanish. If true, this would break the laws of physics. Some think the information is encoded in the Hawking radiation, just in ways we don't yet understand. Others propose the information escapes to another universe through a wormhole. If black holes are portals, the information isn't lost. It's just moved elsewhere. The paradox might be a clue, not a contradiction. Black holes could preserve the universe's secrets by sending them to new worlds. The solution could change our understanding of reality. The mystery endures, but the possibilities are profound. Let's imagine the journey. As you approach a black hole, gravity stretches Would you take the leap into the unknown? What new light might await on the other side?